It's such a pleasure to see so many people here today for the auto-grading session for Moodle. One thing before we start, I wanted to say how we chose your topic. We were after the CEFI conference, and we were discussing with the directors of Learn. We had a lot of contributions from EPFL, which were not actually from the Learn umbrella, meaning all the learning centers with CAP, with SEDE. Hello, Jessica, the executive director of Learn I was talking about. And we said, there are people who are outside of Learn who contribute to the educational EPFL. And we like in particular your paper because it was about assessments and about grading and about finding a way to extend and have a more large automatic system of grading assignments. So it's a pleasure to introduce today Bovel, Benoit, Morawiec, and Hamza Remmal. I will let you speak for yourself. You have already a procedure to talk. Enjoy the session.
Perfect. Thank you very much for the introduction. Hi, everyone. Bon appétit. Thanks for being here for this presentation about auto-grading for Moodle. So I'm Matt, that's Benoit, and we have Hamza here. And we also have Barbara and Jamila, who are all part of the core team of the project. And we have also many other people here that helped us. So yeah, thank you, everyone. And this is a Drill-funded project. So as you might know, Drill are funds for education-related projects here at EPFL. So we pitched the project about 1 year ago, and we made a proof of concept for this auto-grading for Moodle, and that's what we will present today. Okay, so what is our problem? We are teaching for, well, we are assisting for very large classes with Hamza. In first year, they have up to 600 students. In second year in computer science, we have classes with 400 students. So of course, that's a lot of people. And we need to have exercises that are graded and that provide a good feedback for the students. And luckily, we are teaching computer science. And it turns out that this is something that we can grade automatically pretty easily. Programming assignments are a natural fit for automation. Why? Because we can write what we call unit tests to check that the student's code behaves as expected. So the idea of a unit test, if you're not familiar with it, is very simple. We consider the student's code as a black box, and we simply test with some input that the student's code do what it should do. So in this case, if we ask the student to implement a division, we will check that if we divide 8 by 2, the result should indeed be 4. If we divide by 3, here we have a result with a decimal part, it should also work. If we divide by a negative number, then we should have a negative result, etc., etc. And the students can then get a report and know exactly which test passed and which test didn't pass. And we can go from easy test to hard test to provide a detailed feedback. Okay, so we are a lot of courses to do that, nothing new here, but it requires some infrastructure to grade the homeworks from the students automatically and to provide feedback quickly. And we surveyed what people were doing in the IC faculty, and we had about 20 courses, each using a different system. So it means that we have a lot of duplication in the work that is being done by the teaching team, right? So of course, we asked the question, could we develop something that can be used across several courses? So we started by identifying some requirements. So what do we want to do? We want something that is general so that it can be used by the different courses. So we don't want to develop something for a specific feedback format or programming language. We want really a platform that can be used by everybody. We want something simple that is easy to operate by the students, by the teachers, and by the system administrators. We want something automatic that was really needed for us. We want students to get the feedback without any human intervention. We want something that scales. because I will tell you more about that later, but we use that during exams, and there we have really a very big load on the system. So we need something that scales to thousands of concurrent users without any problem. And finally, we want something local. Grades are sensitive data, so we want this data to stay within the EPFL network. So our project only relies on EPFL infrastructure. Okay. So we developed and tested this auto grading system. It was funded by Dre, I said that already. And so today I will present you the goal of the project. That's done, that's what I just did. I will give you now an overview of how the system works. And we will show you two case studies about what we use the system for. First one with automated equational reasoning proof that we grade automatically, and a use case with Python notebooks that you might be familiar with. And in the end, we will end with some conclusions. Okay, so our system, as you saw in the title, works with Moodle. So why Moodle? Because it exists and we didn't want to reinvent the wheel. It's known by students and staff. Everybody uses Moodle here. And we have already support at EPFL. So we have a dedicated team that provides support for Moodle for teachers. Okay, so I will show a live demo directly of what our system does exactly and what you would see as a student using it. Okay, so here I have Moodle, the moodle.epfl.ch that you know, and I have an example assignment, which is very simple. It's just an assignment where I have to write a Python script that prints hello world to the student output. Okay, so let's maybe try first with something wrong. So I will write hello EPFL instead, and I would expect this to fail. So as a student, so you can see I'm in the familiar Moodle UI. This is an assignment, and I can add a submission here. I have a drag and drop zone here where I can drop my file, and I will drag it here, and then I save the changes. Sorry, I just forgot I should switch to students to show you exactly the workflow. Okay, so I created my submission. It's in draft currently, but I see that the files are here, and I need to confirm that I want my files to be graded. So I click Submit Assignment here. Yes, I'm sure that I want to continue. And normally, if everything goes well, which is the case here, I see that my submission was successfully uploaded for grading and that I will get a result soon. If I reload the page, let's see if I already have a result. Yes, that was fast. So as you can see, I have some feedback here. I see that the auto-grade bot graded my project. It was quite fast, and I see that I have 0 points because I don't have the correct output. So just to convince you that it really works, I will try with the correct output here. Okay. And I will submit again. I save the changes. I submit. I continue. And now again, within less than a minute, we should have a result. Okay, now I have the total amount of possible points for this assignment. Okay, so as you have seen, we have several attempts here, but I will show you right after that's something that can be configured by the teacher. So you can choose to let the students submit only once or several times or as you want. Okay. Good, so that's what the students see. What's behind the scene? So that's just the demo that we saw. What is the backend? The front end is Moodle. What is the backend? So for the backend, we use a tech called Docker. Who is familiar with Docker here already? Okay, almost everyone, so I will go quickly on these slides. But what are the advantages of Docker? So you can see, if you don't know what Docker is, you can see it as lightweight virtual machines that allow you to define a computing environment, install what you want there, and then we can run these things called container to grade the student's code. So the advantages is that it abstracts over any computing environment. It's quite well known, as you saw. It's really used a lot. And it provides some good sandboxing features. It means that when we grade student assignment, we are sure that the different grader will not interact with each other, right? They're completely separated. So what we call a Docker image is this definition of the computing environment. I will not go in details here, but basically what you need to do at the low level, if you are a teacher, is to define a Docker file. And this file is a text file that defines what you need to grade the student's code. So in that example here, we see that we start from an image called Python. It means that we will have Python installed there, simply. Then there are a bunch of other comments. And finally, you write how the code of the students should be graded. So here to grade the student's code, we run a script called grade.sh. So it could be as simple as that, 5 lines, where you install everything that you need, and then you grade the code. Okay. And from this file, you get a Docker image. And that's what you need to provide in the Moodle UI to grade the student's code. So then, okay, there is a script there that will grade the student's code, but what should this script do? Well, we have quite a simple contract. The script will find the student's file at a specific path, so at data/submission, and the script should write a grade as a JSON file in feedback/grade.json. That's the whole contract. And in between these two things, you can do whatever you want in the image. If you want to span a server, to call an API, to do tests, to run any software, you can do what you want. So in that aspect, our system is really quite a low-level bridge between Moodle and Docker, and then you can do what you want. Okay. So I will show you the options that you have as a teacher on Moodle. So if we come back to Moodle here, so now I'm a student, but I will switch back to my normal role of teacher on this course, and I will show you how this Moodle assignment is configured. So if I go here and I click settings, so this is a normal Moodle assignment. So you have all the features that you would normally have with Moodle assignments. So you can choose from when the students can submit until when, etc. And the only different thing is this submission type autograde here that you need to tick. And then you have here the name, the URL of your image, of your Docker image. And it could be hosted somewhere private, so you could provide a username and a password. And that's all. That's all you need to configure. You should just also make sure that you accept feedback files here. If you want to provide some feedback files to the students, that's something we also support. So not only can you set the grade, but you could, for example, generate a PDF or an HTML file or a text file or anything that you want to provide feedback to the students. And that will be uploaded to Moodle as well. Yeah, and that's about all. So that's it. We kept the UI as simple as we could. Okay. So where are we with the time? Okay, we are right on track. That's perfect. So okay, that's the technical part of Docker. Maybe you're saying, okay, but what can I do with that actually? So I talked a bit about unit tests, but we will show you 2 other examples because maybe not everyone is teaching computer science here. So I wanted to show another example that we did in our course. So in second year, we teach what is called functional programming to students. So the idea is to approach programming a bit like math. And we teach students to do proofs on programs, okay? So here is an example of a program that we could define. This is a function that is defined piecewise in 2 parts. Is it clear for everyone what this function does? It would compute the sum of the numbers from 0 to n, okay? And it's defined recursively. So if here I call it with 2, I will call f of 2 minus 1, 1 plus 2. And so f of 1 will be, etc. Okay? And this is another definition of another function, g, that computes actually exactly the same thing. It also computes the sum of the numbers from 0 to n. And so the typical exercise that we would ask the students to solve is to prove that these two functions are equivalent. And you can do it by just applying a list of axioms and rewriting the code step by step, exactly like you would do for a mathematical proof. So in a typical exam, we would give a list of axioms to the student that would look like that. So you have the definition of the function that you saw before, and some general lemmas about arithmetic, so commutativity, associativity, identity element, etc. And we would ask them to prove that these two functions, when we have 0 as the second argument for g, are equivalent in all circumstances, so that they really compute the same result. And like in mathematics, you can prove it by induction. So you would say, well, we would prove something slightly stronger. So instead of 0 here, we would have a plus m. And we would prove by induction. We would have the case when n is 0. And then you can just apply one axiom at a time and rewrite your formula and prove that indeed for the base case, if I have f0 plus m, if I unfold with this axiom, I see 0, and then I can replace things little by little, okay? And then we have an induction hypothesis, an induction step where we can use the induction hypothesis and we can do something similar. So I just wanted to show you that because that's an example that is not just unit test, but we can really here ask the students to upload a proof script like you see here. And then it's easy to check automatically that indeed the rewrite that they did at each step is correct. So I don't know, maybe that could be applied for math courses or for other things than functional programming, as you see here. But that's really something that could be done also with our tool. So there are many tools that you can use to implement that. These are called interactive theorem provers, and you have two examples here. Coq is a very well-known theorem prover, and in our course we actually used Lisa, which is a theorem prover developed here at EPFL by my colleagues. Okay, let's see for the other use case, the automatic grading of Python notebooks. So I'll stop sharing my screen, and Benoit, you can share yours.
I share my entire screen. Please interrupt if I don't speak loud enough or if I rush. So this case study is about Python notebooks. Why Python notebooks? Because it's a really convenient way to provide an assignment to your student. You can have explanation as well as a coding environment. So let's move to Moodle, where I created an assignment. Now we switch to the student view. Here I have an assignment called AutoGrader. Attached to the assignments, I have a file. Yeah, it's a notebook entitled .ypnb. I can download it. Okay. So here we see that we have some explanation and we have placeholder for the implementation. What I will do, I will import this file in Noto, which is the Jupyter lab provided and maintained by EPFL. It's really handy and convenient to work with Jupyter notebooks. Here I will just load the file entitled. So here as a student, I'm completing the homework. I can run the cells, verify that what I did is correct. So here we have a test case that was included to see if my implementation is correct. And here we don't have a test case. The tests are hidden. They are only stored on the teacher side. So now that it's done, I can download the file. And I can submit it on Moodle. So I will add a new attempt, choose my file. I save the change and I submit. So now we need to wait up to 10 seconds for the grading to process. And now here we see the feedback. So I have a grade of 0 and the feedback. So we have a feedback file in the JSON format. So some test case failed. And yeah, okay. Let's see what was wrong with the assignment. Okay, it should be good.
I would be interested to see the feedback. Can you just show the JSON a bit to see what type of it seems to me your solution was correct, but never mind. Let's look at the JSON just to see. Can you just explain what we see?
Yeah, so basically here we see for each of the question this. Okay, yeah, for sure.
Could you zoom a little bit? We don't see anything online.
So open it with VS Code. Is it better than the text?
Yes, better.
So basically, for each of the question, we have the question name, we have the score that we had, the max score that was possible, the visibility of the test. So the first test was visible, but the other was hidden and stored only on the teacher side. And here we have the test case that failed, error at line 10. We have a problem with this. Let's say someone in 1 equals 2. So maybe I didn't submit the proper file. Yeah, okay. The file I submitted wasn't.
So just maybe a comment on that. So here you saw really the raw output of the underlying tool. But typically, if we work with first-year student, we would not display this feedback as is directly, but something nicer with some explanation in English. And that kind of feedback we would only show to like second or third year students that are supposed to know how to interpret that kind of files.
Okay, let's verify.
So then there's a second thing that will translate this raw feedback into a sentence feedback, something like this.
Yeah, yeah.
Whereas the test case of this didn't work or something like that.
Yeah, so the Hamza did that for the first year course, for example. He generates a nice HTML file where you really have different rubrics and you see exactly which test should fail, etc. Yeah.
And provide examples if you want, because we have many of them that are.
So hopefully now it should be good. I verified that the content is correct. Save change. I need to submit. And now we have a grade of 5 out of 5. If we again go and see the feedback file in JSON. So here we see for all of the questions we had the max score and then all the test case pass. So this is on the student side. Now you may wonder what is the magic about besides the scene. So we are going to see on the teacher side what enables to create such auto-graded assignments are tools like NBGrader or AutoGrader. And those are auto-graded tools for notebooks. AutoGrader is the study case we will have here because it integrates really well with the Noto platform. It is a tool that is developed by UC Berkeley University. And so now we will go through the step on Noto to create such an assignment. this notebook to see the philosophy behind Noto. The idea is that you write only once the notebook. You write the teacher version with the solutions, and then you provide some test case. And AutoGrader automatically takes care of releasing the student version, hiding the test, and removing the solution and replacing them by placeholders, like the Python ellipsis we had before. When you pass like this. And okay, yeah. And it also creates a zip folder that you just have to download, and you can then create any student submission against this zip file. So let's go through the step. We don't need this anymore. Let's go through the step of creating an assignment together. So for this, I will create a new notebook with the Python kernel. The first cell is telling AutoGrader that this is an AutoGrader notebook. So I will just copy the one here. It is a row cell. Then we can provide some markdown explanation. So this is my auto notebook test. We can create some questions. So this first delimiter takes the name of the function. So it's sum. And then the number of points. We will give it 2 points. It's also a row cell. Then below, we will be able to provide the implementation. Wrapped with this delimiter of begin solution and end solution. For AutoGrader to know which part of the solution cell it needs to remove, we need to mark the section to remove with begin solution and end solution. And then here we have the placeholder for the student submission, for the student implementation, and now we can provide some test case with begin test and end test. And here, the test function for the test takes place as function, and the argument is the function or the student's symbol environment that we want to test. So AutoGrader will take care of providing the symbol from the student environment to the testing function. Then we can have some tests as assertions. Okay, so now an important step is to verify, does the test I wrote, are the tests I wrote in adequation with this implemented solution? There, as we see, there might be a problem because 3 and 5 is not 7, but I can verify this by calling and running the cells. And I put the in-your tag so that this will be removed from the student side, from the student notebook. So I run this first cell, then I run the second cell. And yeah, we'll see that we have a problem with the test. We need to adapt them or change our implementation. So I can run it again, and now it works fine. Let's create, so those tests will be visible on the student side, as we had here in AutoGrader. This student, as you can see, if we don't mark the test as hidden, they are still visible and the student can run them to see, okay, does the job I did work well or not? Now we can create a second question with the tests that are hidden. This will mean that the tests are only stored on the student side on the server, and the student won't be able to see them. So I copy paste, begin question. This time we will have the multiplication and I give it 3 points. It's also a row cell. Below I will start the implementation. Verification of A and B. So I change the symbol. Now I can begin the test as before. It's the same thing. We have a test function. This time it's test mult. The symbol we want to be imported and be provided by author is the multiplication. So I also need to change the test. Okay, and to go from a test that are hidden from a test that is visible, there is just this quick mark to be done, and AutoGrader will take care of removing the tests. I can just run the test to verify if the implementation and the test match. So it's mute. It's
You still have some there.
okay, yeah. Mm-hmm.
It was just to test if it works.
Exactly. So now it works fine. As we see, we can quickly go from, we can quickly have the teacher version with the implementation and with the tests. And to release the student version and this grading zip that is required for our auto-grading platform, we only have to do one more command. So we use the auto tool, which auto. It's installed on Noto platform. So here I have my teacher version of the assignment.
You still have a mistake actually in this one, in the notebook at the end.
In the notebook at the end.
Yeah, just the very, very last entry. Go to the notebook.
Yeah.
The very last entry you wrote. No, to the other one. This is the one that you create the new one. Go to the end.
This is the new one, and this was the previous one.
Oh, okay.
Okay, yeah, for sure. Yeah, it lacks the end question
It
for
should
sure.
be end test at the end. No. It should be end test as well, no?
We have the end tests.
No, the other one. Or you were just before. In the other file.
C'est pas le bon fichier. The other file.
Okay.
La avant-dernière cellule.
Yeah. Begin test. Okay, yeah, and begin test and end test. Yeah. Thanks a lot.
Okay.
You probably see it when you run also, no?
So the last thing to do is you use auto assign with the master notebook. So it's untitled. Then I create the destination folder and verbose to see some details.
So maybe we should just continue because if we want to discuss for like 10 minutes. But the idea is that you run this command, you get a zip file, and then you can generate the auto-grading image from that and use it in the plugin. Okay.
Mm-hmm. I can show you the other. Okay. You can touch it. Sorry.
Okay, so I'll quickly wrap up with the conclusion. We're already 4 minutes late. So yeah, we show you the system in general and 2 use case studies. We actually already used the system in 8 courses over 3 semesters. So that's all computer science courses, but that's quite a lot with a lot of students and a lot of different languages. So Java project, C++, but also assembly, Verilog. We also used it to grade the distributed algorithm projects, where we simulated some network issues inside the containers. So you can really do a lot of things. We also used it for a final exam. That was quite a challenge, but we did that on the virtual machines from EPFL, where students could access Moodle. And thanks to the help of different teams, that worked very smoothly. And the students all submitted at the same time, even if we told them very early that they shouldn't. But that was not a problem because the system absorbed the load without any problem. Yeah. Okay, so we have some future work planned. So we will improve the UI, for example, so that the student can follow the status of the submission, see if the grading has started. We would like to integrate with the Pocket Campus app better, and maybe integrate with Noto also on the student side. Because as you saw in Benoit's demo, here he was working with the notebook on his laptop, but it would be nice if the students could work on Noto directly. And there actually is a plugin to allow students to submit directly from Noto, so we would need an integration with this other plugin. Okay, I would like to thank everybody from the project. So the Drill team I presented before, but also the Moodle team, the ICIT team that manages the cluster in which the grading jobs run, and the CD from which we have Pierre-Olivier and Patrick here. Cool, thank you very much.
We have Simone who raised the hand and already posed the question 10 minutes ago. So Simone, please.
Yeah, so I saw that your first question was about the integration with Noto. So
Hi.
I answered that.
So yes, you answered the question about the Noto plugin, which will be very interesting. And the second one would be integrating the Safe Exam browser also in that. So on one side, it's possible to code the Safe Exam browser so that you can only access some pages. You're not hearing me?
No, we hear you.
Okay. And then what is missing right now in some of the quizzes in Moodle is the possibility that the Moodle itself checks that it is integrated in a Safe Exam browser environment. Maybe this question is too difficult. I will have to contact you for that.
Yeah, but I think that should work with because you can access Moodle from any browser, so I don't think we would need anything specific there.
Now, what happens is that it is possible to configure Moodle so that it don't even open the quiz if there is no Safe Exam browser on the other side. So there is like a token on the client side that is sent to Moodle to say, okay, I'm a Safe Exam browser. Give me the quiz.
Okay, and then the student can only see the quiz, but nothing else on Moodle.
Exactly, it can only see the quiz if it is on SEB, and it can only see that quiz and nothing else.
Oh, that would be nice. We did something more coarse-grained for the final exam, where we just asked manually the Moodle admin to disable the chat so that the student could not talk, but they had access to the material of the course, which was not a problem for us, but indeed it would be nice to be able to fine-grain that. Yeah.
So it means it was just the general Moodle of the semester, and there was one assignment which was the exam.
Exactly.
I was thinking it would be a separate one where you say for the exam we have a separate Moodle.
No, we could imagine that, but
okay.
At ETH, they have two Moodles, one for the exams and one for the semester. But that's a lot of maintenance in addition, I think, if we asked the team, Moodle team. I have a question for the usage during the exam. The other day, I was describing this to somebody, and he was a bit upset about the idea that students could get feedback during the exam. So what's the rationale that you have to actually use the grader during the exam, and what type of feedback do students get?
So from our experience, it avoids a lot of stupid mistakes. For example, forgetting to submit a file or submitting a file with the wrong name. So really to sanity check the input, it's already super useful. You don't want a student to get 0 just because they missed a file or they misnamed one, right? And I think for the unit test, it's also useful, and it also avoid like that they go in the wrong direction or that they, yeah. So in that sense, I think it's actually more fair if they can track their progress in real time.
Yeah, that was my opinion as well, that it depends how you define the learning objectives. And there is no need to test people on stress resistance if it's not the learning objective or on other stuff. But still, there was a bit this notion that if you do, you can have 10 points and that during the exam, you can see, I don't get point number 3 right. And so I try again. You will not be able to solve it by yourself. Like it's like a bit l'école des fans, everybody wins.
Yeah, on the other hand, when we look at the distribution of the results, it's like a normal exam. So if you, of course, you make questions that are slightly harder if students have real-time feedback. But apart from that, we have a very good distribution. So yeah.
You could also track, right, how many times they
Yes.
test a certain unit. So that could be something you take into account. You see, okay, there are the students who could not write themselves because they needed to run unit tests 10 times. So it's not just a file that they forgot, for example. So
Indeed, yeah.
I was wondering, when you sit in the programming related exams, have you evaluated anything else like related that is not like a result from a method that you code? For example, can you also evaluate if a student uses a specific feature of a programming language that they are learning during the course, or that's more really difficult to?
Yeah, so you could, but that's out of the scope of our project. We just provide really the low-level platform, and then it depends on which language you use. And some languages have feature flag that allow you to disable some features. Yeah, we have been talking about that a lot in the framework of Scala. Yeah, wondering if we want to implement something like that. Yeah, what we did, however, is, for example, run a formatter to check that the code has some style. Or yeah, some things like that. And in our exam, we also graded the proof. So that's the case today I showed before, where students grade the proof, and we checked that the proof was correct.
The Noto plugin that we have already would avoid the download upload type of mix-up, because it opens the file tree that you have on Noto, and you have to pick the file directly there, so that you don't get you don't need to download several times the same file.
Yeah,
it would be very nice to integrate both, and to have an integration for what is Jupyter on one hand, and then keep your plugin as it is for all the people who do other stuff outside of Jupyter.
Yeah, so that's definitely one of the things we would like to do in the future. Yeah. So yeah, but on our side, we're at the end of the proof of concept phase. So now really the question is, can we transfer the ownership of the project to other teams to ensure long-term maintenance and support? And yeah, we're in the process of doing that.